Hello, and welcome back to some more Unit 1 videos. So today I actually got some feedback from you guys. Sorry, I dropped my pencil there, my Apple Pencil. I got some feedback from you guys because I wanted to see how things were going. And I know that there's a lot more to be said about other functions, particularly more of the more challenging functions like rational and logarithmic. But in this video, I'm going to address the question about the difference between A and B. So maybe I'll title this. I'll go ahead and give this a nice little title: Function Transformations. The difference between A and B. I'll make those capital. Yeah, I like that. All right. So one of the questions I've been getting is, how do I know when something is supposed to be interpreted as a vertical stretch / compression or a horizontal stretch / compression? And this is a great question. I mean, really, this is a fantastic question because it's tricky. It is. Even sometimes myself, I get a little hung up on it. So I'm going to show you something here. First, a quick reminder that our function transformations look like this. Do I like this thickness? You know what? Do I like this better? I think I like the second thickness. I'm going to go with that. So I'm going to go A, F of B, X minus C plus D. This is something we kind of want to just burn into our brains here. And I know I'm asking a lot of memorization from you in this first unit, but just trust me that this memorization is going to go a long way in this class. I think it's going to help you out a lot as we go out through, as we explore each function. So let's talk about A versus B. Now, as a quick reminder, our rules are if the absolute value of A is greater than 1, we call this a vertical stretch. I'll write that out. If absolute value A is between 0 and 1, meaning it's just some fraction, right, less than 1, don't worry about whether it's positive or negative. It's just the idea that it's smaller than 1. Vertical compression. And, of course, if A is negative, I call this a vertical reflection. I know. We already have this, right? You might be saying, Mr. Spick, I already know this. I say, I know. Just bear with me, right? And as a reminder, B, if absolute value B is greater than 1, we call this a horizontal compression. Let's say compression. Oh, it's going to go. Ooh. It's getting a little icky there. Let's try this again. If absolute value B is between 0 and 1, call that a horizontal stretch. And if B is negative, that's a horizontal reflection. I guess I could have just wrote H instead of horizontal, but whatever. Reflection. Okay. But the challenge is not remembering this, it's identifying which is which. So I'm going to show you a quick example here, and I think you're going to see that these things, the difference is almost arbitrary, meaning it's kind of meaningless, that we interpret it one way or another. But I'll tell you, the reason we put the distinction is because, and this is what you want to really note down, so I'm going to put a star for this. B affects horizontal shifting. A does not. That's the difference, okay? And that's why we would really care about this business in the first place. So let's look at a couple examples here. Example 1. So I'm going to suppose I have, let's establish a parent function, f of x equals x squared. I like this one a lot. So if I look at x squared, let's look at what an a value looks like. So I'll do this in red. If a equals, let's say 4, or you know what? I like 9. Let's say 9. Suppose a equals 9. Then a f of x, well, a is 9, and f of x is x squared. This would mean a vertical stretch by a factor of 9. You say, well, yeah, I got that part, Mr. Spake. But look at this. Suppose I now say if b equals 3, well, what is that, right? And note, I want you to notice something. A is on the outside of the function. It's not. You have x squared, and then you're multiplying that output x squared by 9 by a. A is multiplying the output. Here, b is multiplying the input. So you're going to say, then this is f of b times x. Because b multiplies the input, not the output. It goes inside those parentheses. And this looks like 3x squared. You see, I don't put 3 on the outside of those parentheses. 3 is multiplying x, and that quantity, 3x, is getting squared. But, well, first, note that this is a horizontal compression. Using our rules, this is a horizontal compression by a factor of 3. But hold on. Look at 3x squared. Do you remember how to, what is that? What is that? 3x squared, well, to square a number means to multiply it by itself. It means 3x times 3x. Well, what's 3 times 3? That's 9, and x times x is x squared. Whoa. Hey, wait a minute. This guy and this guy are the same. So, the graphs look the same. We can interpret the stretching / compressing of it differently depending on the way we express it. And that's what I meant earlier by being a little bit arbitrary, meaning it's not that important whether you interpret this as a vertical stretch by a factor of 9 or horizontal compression by a factor of 3. I mean, really, it's not, because they are the same thing. Look, I'll do my graph. Nice, I already got x squared there. By the way, just hit this home. This is f of x, right? If I say 9 f of x, notice, and I'll change that to red so you can kind of see the real difference here. Notice how that vertically stretches it, right? And now, I'll do another color. Can we do green? Let's say f of 3x. Okay, black, sure. I'll make it green because I like it. Well, that just overwrote the line, right? Look at that. They're the same line. I'm changing colors. They are the same, right? A compression horizontally by a factor of 3 is the same thing as a vertical stretch by 9. And you might be saying, now what the heck, right? What the heck? Why do I care about this, Mr. Spake? Why can't I just say it either way? Well, I mean, you kind of can, right? Depending on what you see. If you can somehow get that 3 out of there and square it and make it a 9, you're more than welcome to interpret that as a vertical stretch by a factor of 9. But what if there's a horizontal shift? This is where it's going to look a little bit different. So I'm going to go back to my notes. Oh no, I thought I would have more space. I really wanted to use more of that space. Shucks. Oh well. On to the next page, I guess. There we go. Alright. Let's go to pen. Now, I'm going to have the same a value. Okay, a equals 9. I still want to do this in red because I like the color coding consistency. A equals 9. And I'm going to say C equals 4. Okay, so what does this look like? Well, if this is a f of x minus c, because I just have the a value, I just have the c value. Notice I'm not bothering writing b and d, right? I'm just writing what I got. Well, this would be 9 times x minus 4 squared, because f of x is x squared, so the input x minus 4, that's what's squared, right? Compare this to if b was 3 and c was 4. Well, then I would have f of b times x minus c, right? And this would be parentheses, right? Because this is the input in parentheses. Whatever's in here is getting squared, and this is 3 times x minus 4, like so. Okay, well, can you square that out? Well, yeah, I mean, you can, right? I'm going to interpret this. I'm going to show you two different ways. I can rewrite this as 3 times x minus 4 times itself, right? This is what I meant by squared. And then, well, 3 times 3, that's the 9, and there's the x minus 4 squared. So, in one instance, it might look like this. Oh, that's ugly. I mean, okay, I guess it's a quadrilateral, but I was really going for a nice rectangle. Let's try that. Okay, that's better. So there's with my interpretation of vertical stretch, right? But if I multiply the 3, if I distribute the 3 here and here, that's going to look like 3x minus 12 squared. And if you don't remember distribution, Google that real quick. Distribution means multiply, right? So 3 times x and then 3 times negative 4. That's what that is. And I'm going to box this, right? Now see, with the left example, this guy, you can easily tell, or well, I guess more easily tell, that it's a vertical stretch by 9 with a horizontal shift right 4. But with this right one, not so much, right? You can kind of see that the horizontal compression by a factor of 3, but the 12 throws you off, right? Because if you don't pull that 3 out, if you don't factor the 3 out, you would think that it was shifted right 12, but that's not the case, right? That isn't the case. You have to factor that 3 out, so it looks like this form, 3 times x minus 4, that thing squared, to really see that horizontal shift right, okay? And I'll show you again that these things are equivalent. So, two ways to write it, right? 9, and then I said x minus 4 squared, looks like that, versus 3x minus 12 squared. It's the same line again, right? They're the same thing, but it's two different ways to express the exact same function, okay? One of them, if you're looking at the red, if that's what I give you on an exam, if that's what you're provided, you're going to interpret that as a vertical stretch by 9 with a shift right 4. But if I give you the green one, you're going to say, oh, hold on. Let me factor out b, 3 times x minus 4. Okay, now that I factored out b, I'm going to interpret this as a horizontal compression by 3 shifted right 4. Okay? And it's all just about where that 3 or 9 is. Okay? If it's in those parentheses, you're going to interpret it as a B. If it's not, you're going to interpret it as an A. And I think that's it. I hope this kind of answers the distinction between A and B, in that that's really not all that different, right? They really aren't. And it's, I think, even more apparent when you look at absolute value. Absolute value is just silly. Look at this, right? If I do 4 times the absolute value of x, well, okay, it looks like that. I wish it would not default to purple. I want red. Red. Okay, so I do that versus absolute value 4x. Oh my goodness. It's the same thing, right? Depending on where that 4 is for a test question, that's when you would interpret the 4 on the outside means a vertical stretch by a factor of 4. The 4 on the inside means a horizontal compression by a factor of 4. And that's it, okay? Just try to remember whether that coefficient, that number, a or b, is it on the outside of the function or is it on the inside? Is it multiplying the input directly, or is the function doing its thing and then you're multiplying the output? Okay. And I think that's all I have to say about A and B. I hope this was helpful. And now I'm just going to ramble on for a few more seconds here and show you a quick example. In pre-calculus, this is a spoiler warning. And don't get scared. I'm not going to make you do any of this year, okay? This is a whole year from now. We're going to deal with stuff like sine graphs in pre-cal, and a sine graph can get shifted as well. Right? I can shift it like over 2. And if I put like a 4 here, right? It's can you see the horizontal compression? Well, gosh darn it, this one's better as a visual, isn't it? Don't you think? I mean, look at this. That's horizontal compression. That's so much easier to see, isn't it? Right? If I delete that 7, and then I put that 7 there, imagine literally squeezing that in from the left and right. Oh, man, I didn't even realize that. Horizontal compression is so much easier to see with a sine graph. Wow. And then if I put the 7 out here, oh, now see, that's a vertical stretch. See it? You see the kind of how it's different though, right? You still horizontal compression and vertical stretch still, they do similar things, but when you got something like a sine graph, that's when this really starts to matter. Okay, I'm gonna show you again, and I don't even care about the -2. Look at 7 sine of x, and look at sine of 7x, right? One of those is clearly vertically stretched, and the other is clearly horizontally compressed, right? And this distinction does matter, right? Because, well, spoiler alert, these are used for waves, and I mean every type of wave that exists, sound waves, but I can't list other waves. Come on, Mr. Spake. Whatever, wavelengths, okay? Anything wave. This happens, okay? So it may be that 7 times absolute value x is the same as absolute value 7x, and it seems like the distinction between interpreting that horizontally or vertically doesn't matter. But as I just showed you with a sine graph in pre-calculus, it does matter because you can visually see the difference. Okay? And there you go. Okay, there. I like that we explored that. I hope that the final little piece put the cherry on top and seeing the difference between these things. And it's going to matter more in the future than it is right now. Okay? Okay. Thanks for being here. Thanks for watching. I hope this was helpful. And I hope you have a wonderful rest of your day.